The rocks that compose the spectacular mountain scenery of the Teton Range were mapped by U.S. Geological Survey geologist Dr. John C. Reed Jr. between 1962 and 1970. During these summers, Dr. Reed also monitored the extent of the Teton Glacier, which had been receding throughout the first half of the 20th century. In this video recording, made in July 2013, Dr. Reed discusses the features associated with the Teton Glacier and describes how he and his team monitored its behavior.
Our main job was to map the hard uplifted rocks from which the range is carved. However, just as a little side project, we got kind of interested in the modern glaciers in the Tetons. It turns out there are half a dozen or more active glaciers in the Teton Range, the largest of which is the Teton Glacier, which we see from here. And for several years, we would go up once a year and survey a line of stakes straight across the glacier, and then we would come back the following year and resurvey them and see how far they'd moved. And by doing this, we determined that the glacier is moving about 30 feet a year. Now, these glaciers that we see today in the Teton Range are not relics of the great ice sheets of the Ice Age. These are glaciers that formed during a period that was called the Little Ice Age, from about 1350 to about 1850. So the Teton Glacier is really a recent glacier, and what we did, we surveyed our line just above the gray area that you can see in the picture. And that gray area, if you'll notice, is a U-shaped deposit of rocks. And that is the terminal moraine, the moraine that is formed at the end of the glacier.
On this image, the black dashed line indicates the location of the line of stakes that Dr. Reed and his team placed in the glacier each summer. When they returned the next summer, they surveyed how far the stakes had moved, and in this way were able to establish the rate at which the glacial ice was moving downhill. The red dashed lines show the approximate position of the ice front in various years. Overall, the glacier has receded over the past century, although at times there were slight advances. One of these advances took place in the mid-1960s, as you can see by comparing the red line indicating the ice front in 1963 to its location in 1966.
A glacier, as you may know, forms anywhere where you accumulate more snow in the wintertime than you melt in the summertime. And if that goes on for enough years, the snow compacts and forms glacier ice and begins to move down the slope. The ice melts at the lower end. So you should think of a glacier as a conveyor belt, not as a bulldozer. It isn't that the ice is pushing those across the front. There are two parts to the glacier. There is a line above which more snow accumulates than melts, and below which more melts than accumulates. And the position of the snout of the glacier depends on the balance between those two. And the position then, you talk of a glacier retreating, but the ice doesn't move backwards. It's just that the front melts back faster. The ice is always moving downhill. And in this picture, you can see the blue ice in a dark patch on the left-hand side of the glacier. That's the actual glacier ice. And the rest of the glacier is mostly covered in snow, most of which will melt in the summertime. You can see below the glacier a series of scoured bare rocks with a few trees on it. And those are the rocks that were polished by the actual Ice Age glacier, which occupied the same valley. As the glaciers advanced down the Teton canyons, they polished and smoothed the rocks in their beds. And in this case, if you look at carefully, you will see parallel to the trekking pole the scratches left by rocks which were carried in the base of the ice. And the trekking pole is pointing in the direction that the ice flowed.